Hello, I'm Steve Rakusik with South Dakota Public Broadcasting.
And I'm Dale Droege with the Professor of Biology at Dakota State University.
And today we're going to dissect the dogfish shark.
Yep.
I got a question for you. I know in the past on the website we have a dissection of the perch. So why do two different fish?
Yeah, well, they're two very different lines of fish. Sharks are a member of a group called chondrichthyes, and that line evolved first, and over 400 million years ago. And they have a cartilaginous skeleton we'll look at later, a denser body, just some differences in terms of the various structures. But they have what's quintessential in all fish is these paired appendages. So they have the pectoral fins and the pelvic fins, and these help for maneuverability. So the muscles, the motions or the power for swimming comes from the tail going side to side, but it's these paired fins that allow these animals to be much more maneuverable and to elevate themselves in the water. And then the other major innovation that sharks were the first vertebrate to show were jaws. And jaws were a huge change because jaws now allow you to eat larger and more varied food items. And so those two things together have pretty much led to an explosion of different types of vertebrates.
Let's say I bring in we have a perch right here. So bring one in. What's some of the differences, maybe similarities?
Well, I'd say one of the differences is in the density of the body. The sharks do not have a swim bladder, where perch do. They have that internal gas-filled bladder, which allows them to remain or gives them buoyancy, lets them stay at a constant place in the water column, where sharks, if they're not swimming, will sink.
Okay.
So that was a huge change. They also sharks have the gill slits are external, and so you can see where the openings. You can see where the openings to the gills are external, and so each gill area has a pouch, where the gills of bony fish like perch are covered by this operculum, this bony structure. And so that is also this is a pumping mechanism that allows them to breathe while they're remaining fairly motionless. Again, sharks have to move to force water over their gills. Then, of course, the fins themselves, the bony fish have ray fins. The fins are supported by these rays, where the fins of sharks are more fleshy.
How about the outer surface?
The scales,
here?
Scales are very different. The bony fish have bony scales. They're tiny, bony scales that cover the body, where the shark skin is covered by tiny little tooth-like scales. They actually are covered with enamel. And if you run your finger over it, you can hear or you can feel how raspy it is. At one time, before modern invention of sandpaper and things, shark skin was actually used as a way of polishing, fine finish of furniture. It's also shiny too, which you don't hear so much anymore. We used to talk about shark skin suits, and that people would wear, and shark skin suits had that kind of shiny appearance to them.
Okay. Anything else similar, different?
Just the difference in the fins. It's just a more maneuverability. Bony fish were just able to are much more maneuverable. They're able to keep their place in the water column. This allowed them to radiate out. There's probably 40 to 60,000 different species of bony fish, where there's less than 1,000 species of chondrichthyes left. And about 400 of the species of those are sharks. Most of them are skates and rays and things like cousins of the shark.
We can also probably bring in the skeletons.
I did want to mention too. Sorry, I think the mouth is another difference too. The shark mouth is on the bottom, the underside,
show the camera.
and the bony fish, it's terminal. For most bony fish, it's terminal. It's at the end in the jaws.
Should we bring in the skeletons? Just kind of show that quick.
Sure.
And just see the difference there.
Sure. I mentioned that the bony fish have the typical what we think of vertebrate as the bony skeleton, where sharks have a cartilaginous skeleton, and so you can see we even have to it has to be preserved inside of water to keep it from drying out. And it's thought that the ancestors of sharks actually had bony skeletons, but they have now lost that because it's a much more flexible and lighter kind of skeleton. And say one of sharks' problems is that sinking in water. So a lot of things that they do allow them to lighten up the body and give them more buoyancy. So that is one difference, though.
Oh, yeah,
a big
absolutely.
difference. We often talk about the cartilaginous fishes and the bony fishes.
Okay. Slide those back over here. And now I guess should we go ahead and look at
sure.
the internal structures, or I guess we can look at the external structures first.
Yeah, we can look at and that's, again, a 400 million year old design, but in many ways sharks have changed very little over those intervening years, because what they evolved is just a almost perfect aquatic predator. They have a long, streamlined body. You can see how that would, they would cut through the water very easily. They have these powerful muscles to move the tail side to side, which propels them through the water, so they can swim long distances, and they're fairly strong swimmers, and they can be fairly fast, when they have to be. Again, the paired appendages give them maneuverability. The jaws give them the ability to catch prey and chew that prey up or bite it into pieces. They've got incredible sensory structures. They have, of course, large eyes, as you can see, a large paired eyes here to allow them to tell. They have very keen sense of smell. They probably locate most of their prey by distance, by smell.
They have nostrils in it. What do they use?
Yeah, they have the nostrils here. I'm sorry, on the underside of the body here. They're actually blind sacs. They don't open into the nasal cavity or into the mouth cavity like ours do. So the water kind of goes in and out, but there's sensory structures in there that are sensitive to chemicals.
You mentioned something on the front here also before.
Oh, yeah. They have what's unusual among vertebrates. There's just a few other vertebrates that are sensitive to electrical signals. Right here, there are some sensory structures called ampullae of Lorenzini, and these are sensitive to very slight electrical fields. And so when a fish or some other prey item is moving, they're generating electrical impulses in their muscles, and the sharks are capable of detecting that.
And is it just like little pores, or what is it?
Yeah, they're little pores. The things are little structures underneath there that just are sensitive to differences in voltage, and so they can actually locate prey buried in the sand, for example. So there's no way they could smell it or see it, and then they can sense, or they can locate it using these electrical senses. They also, like other fish, have a lateral line system. See, there's a line running along here. These are pressure sensors, so they can detect changes in water pressure. So waves pushing something moving toward them or away from them would create water pressure differences, and they can detect that. And so they really have, they have really strong. You think about what a predator does. They can move. They can find their prey. They can eat their prey. They really have a very classic design. And probably reason why they've survived, all of this time.
I imagine this much movement must take quite a bit of nourishment then, I would imagine.
Yeah, and of course, like if you're going to move around a lot and things, they have to eat a lot. And they are, again, that's, part of their thing. They eat large things, and they hunt fairly voraciously and fairly frequently.
What do we have right here, these little holes on top here?
Oh, okay, yeah. Now, these are called spiracles. And spiracles open down into the gill chambers. So sharks don't use them as much as rays do, but they actually are ways that water then can enter and go down through the gills here. So pass down, so water can bring oxygen in and pass it over the gills. Where if it's coming through the mouth, if you're down on the bottom of the water, if you're down on the bottom of the ocean, near the sand and things, it's going to block that. So it's essentially a second entrance for water to come in to provide oxygen to the gills. Let's see what
You mentioned the skin already. You mentioned that.
Yeah, we should probably about just name the fins again.
Oh, yeah,
I say we probably, externally you have forward are the pectoral fins, which are near the shoulder area. Things are, and then in back are the pelvic fins, and right at the base of the pelvic fins is the cloaca. The cloaca, the cloaca is a common opening of the urogenital and digestive system. So both the end of where the undigested food comes out, but also where babies are born and things like that come out that end. And then we talk about the unpaired. So those are the paired fins. The unpaired fins are the dorsal fin, famous in sharks for always breaking the surface. And then there's a posterior dorsal fin too in this case. And then the tail, which is in many sharks is this so-called heterocircle, or it has one lobe is much larger than the other. It's usually the top lobe that is larger, and as this moves through the water, it forces the head up, and which is, again, a problem sharks have of being so heavy that they need to try to, keep swimming to maintain their position in the water.
Notice there's a couple of spots removed here. Is there
Oh,
something?
yeah, this fish we're looking at today is the spiny Atlantic dogfish. And this is about all the bigger they get, just a little bit, maybe might be a little bit larger than this, but they're a small shark. But as their name implies, they're spiny, and so they'll have large spines near the beginning of these different fins, and the supply houses basically cut those off so that you don't stab yourself with them when you're working with them.
We should mention too, as far as sharks go, as far as the concern is dissecting these.
Yeah, I mean, with any vertebrate, of course, we want to be very careful about how many we use, because we don't want to take too many lives for this purpose. I mean, there is a lot of value in the hands-on type of looking at things, but we try to use them as carefully as we can. And sharks in particular, their numbers have been somewhat unstable over the last many decades, and this is largely due to a lot of human activities and different kinds of things changing in the ocean. So you certainly don't fear these animals are caught. Fishermen catch these, when they're fishing for other things. So, but it's just being kind of trying to be respectful. If you're, use as few of them as you can, and use them, only use them if you're going to spend a considerable amount of time looking at the structures and things like that.
Maybe use the video
and hopefully a video like this or others would then provide some, an alternative means of discovering shark anatomy and structures.
I also notice here, this one has a cut tail here. And the kids might notice that.
Yeah, everybody always asks about that, and things are. There's a couple of reasons, as I understand it. One is that they'll cut them, and if they're going to inject the circulatory system, they can do that through a couple of veins and arteries that run through the tail here. You can actually, through the cut, you can actually see the vertebrae of the central axis of the actual skeleton. And then also, it just tends to make them easier to fit into containers, particularly when they're in pails and things like that. They just pack a little bit better. So there isn't any real major significance to the tail being cut. It's more of a convenience thing.
Anything else you can think of, or should we go ahead and look at the inside?
Can't think of too much else. Yeah, no, they're pretty. And then inside, they're pretty much a very typical, again, vertebrate body plan. We see different kinds of structures, so it's pretty interesting group to look at.
Sounds good.
All right.